Hey there. Now, some of you may know that I've been busy over the past year with organizing a series of monthly in-person meetups. And these are the Tech Arts Meetups, where tech artists and tech arts enthusiasts from, all sort of varying skill levels come together in the Dallas-Fort Worth Metroplex area and just really come together and mingle. We usually start off with some pizzas, and then we're going to move into a short presentation or a long presentation, it depends. And the rest of the time, we're just going to be sharing, connecting, catching up with one another, getting to know one another, and really just inspiring each other with what we are doing. Now, if you are in the area, I would love to invite you to join us. And you can join us and find out more information at www.nelsonlim.com/TAM, where you can register and sign up for our next event because this is an RSVP only event. Over the course of the year, we have accumulated a series of Tech Arts Meetup presentations, which we have recorded and never really got the time to upload onto the YouTube channel. But I'm proud to announce that now we're going to upload all of these presentations as a series onto YouTube on this channel so that you can benefit as well. I'm also super excited to announce that the very first presentation is going to be by my good friend, Peter Claes, who is an expert technical artist at Infinity Ward. Now, Peter has presented a long-form talk entitled How to be Successful as a Technical Artist. Now, throughout the talk, he shares the mental models towards problem solving that technical artists are going to have to need, as well as the skills in the areas of math, science, and coding, and much more that we need to cover and learn. And also he covers the marketing and networking tips and tricks, as well as the trends to watch in this particular area. And there's so much more that he's talked about, and it's really an exciting time to be a technical artist right now. There's lots of valuable nuggets to unpack here that's really going to help technical artists and non-technical artists alike to advance in their skills as well as their career. So I hope you enjoyed watching this video, and if you did, consider liking, subscribing to this YouTube channel so that you will get notified when more content like this comes up. And also perhaps think if you know someone that could benefit from this video, think of it as paying it forward, perhaps share this video with them as well. So enjoy, and I will see you around. Take care.
Alrighty, guys. Yeah, thanks for coming. I look forward to presenting some of the work that I've done over the past decade. So I have been in industry for a while. As you can kind of see, I've gathered some movie posters that I've worked on, including some games that I worked on. So what I want to do today is go over some of the skills that helped me in my career and share them with you, because as Nelson said, this is all about sharing. So let's step through it. So first of all, I am Peter Claes, and who am I, right? So I'm a problem solver. So most of my day-to-day is a lot of solving of problems that comes back in a creative way, as well as in a sort of engineering, programming way. They're sort of inventing new things, and then there's the artist within us as well. So technical arts, it's a bit of both. And then there's some soft skills that I think are really important as well. So curiosity and that eagerness to learn, that's going to come back a lot as well. A good communicator is crucial to be able to communicate to your team, whether it's your leads above you or whether it's people within your team as well. And then just overall, a good idea is to be kind, right? Because you don't want to get known for being, the bastard in the team or something like that. So just be kind to people. In terms of employment history, I've been working in industry sort of professionally since 2009, so it's been a while, right? I started in London, so in the UK, as an effects artist at Cinesite. I worked there for about 2 years, worked on a movie called John Carter. From there, I was headhunted by Method Studios in Santa Monica in Los Angeles, and I worked there first as a lead artist, and then I became effects supervisor for the movie Ant-Man. And then after that, CG supervisor on Captain America. Then after that, I worked there for about 5 years. I switched to The Mill in Los Angeles. So they do more commercials and also game cinematics. So that's sort of another section of work that, kind of came about there. And then lastly, the last 3 years I've been working at Activision, specifically Infinity Ward, on Call of Duty as an expert technical artist. And I'll maybe at the end mention a little bit about the transition between those roles and how these skills overlap. So one of the things that when you start with a new task, or whether it's for your own project or for something else, for someone else, it's these mental models, right? So try to approach a problem from different mental approaches. So basically, from an artistic point, does it look good? From a technical point, does it perform well? Both in terms of the performance in real time. Does it scale, right? Because a small level works, but a huge level can also have some complications. From a physics point of view, does it behave realistically? Also, does it need to behave realistically? Or do you want to go with something more cartoony, something, you know, stylized? From empathic, does it make you feel something? Because generally, if people don't feel excited about it, or they don't feel good about it, they're not really going to care about it. Political, does it offend someone? Is it illegal in some way, right? As working on Call of Duty, if you have to take care of trademarks, or you have to take care of certain protected categories, you got to make sure that, you know, you're careful about the content that you're creating. Financial, how much does it cost to run or build, right? There's generally time schedules and producers involved. So it is good if you can take on these mental models and basically go and step through each of them to approach your task. So about a technical artist, right? Because a technical artist can be so many things. So generally, to me, it is a generalist with domain expertise. So the way that I kind of like to sort of approach it is that my knowledge is like a block of cheese, and there are holes in the cheese. And over time, I'm trying to get more cheese than holes. So what I mean by that is you need to know some computer graphics. So computer graphics algorithms, you generally need to know some mathematics as well. We're going to go into some of the bits of mathematics in a moment, the ones that are particularly useful. Next, some programming or scripting can also be extremely useful to help automate tasks or process large data sets. You need to have an artistic eye, because some of the tools that you're going to be building need to ultimately, oftentimes, feed into either a shot for a movie, or for a commercial, or for a game, right? So that content needs to look good. Next, you need to have some UI or user experience understanding. That's specifically if you're going to be designing tools, so that not only are you creating the tools, but you should use your tools as well, or have communication with the people that are using your tools to create a good experience. Because if they don't have a good experience with your tools, they're not going to end up using them. So a jack of all trades, or a generalist, is a good starting point, and it's also good for yourself, especially people that are starting out in industry, to sort of try and figure out what they enjoy working on, because you might start out in one direction and then explore different fields and discover that maybe you really like programming, or maybe you really like texturing or modeling or animating, whatever it ends up being. Try to be at least an expert in at least one domain, right? So that you can basically go to a company and say, this is where I can provide real value to you. So you have your task, and how do you approach it? Well, this is kind of a divide and conquer methodology. So it's also in programming considered to be abstraction, where you start with a complex problem, in our case the castle, and we're going to break that complex problem down into smaller and smaller bite-sized pieces until you reach an area that you actually can understand. So in this case, your smaller components would be your towers and your walls, even smaller, until you can solve this one portion, which is a single brick. And then from there, you're going to build that back up to that larger sum. And it's a good idea, whilst you're doing that, to work modular. So working modular from a programming point of view means creating classes, creating definitions. If you are a digital artist, you can make digital assets. So these are sort of the tools. And also organize yourself in subnets, where you group functionality together. That's typical for Houdini. That might also be typical for Bifrost or other kind of applications. Blueprints, same thing. So divide and conquer, an example of this, right, for your abstraction. Let's say you have to process 5,000 assets to provide them with occlusion maps. Now I chose this large amount because, well, in these bigger games there are a lot of assets, and not just in games but in film as well. If you have a large environment these days, these environments, they get bigger and bigger, and with more and more denser asset sets as well. So let's say for these 5,000 assets, how can you tackle that? Well, first of all, we got to try and figure out how can we process a single asset. How do you do it for one character, a weapon, maybe an environment asset? How do you do it for a single one? So in my case, I'm going to try and process one asset with my platform of choice, which happens to be Houdini. Now, I'm going to open Houdini, create that digital asset. I'm going to configure some settings, right? So make sure the parameters are tweaked correctly for my needs. I'm going to save a debug file, very important, right? So that you have a way to get back to those settings to, go back and revisit, rerun if you need to a prior asset. Then we're going to execute that HDA, Houdini digital asset, and hope that it works, right? And go through that loop a few times. So what does your digital asset actually need to do? Well, it needs to do some I/O, some input and output. It needs to read a model. It needs to compute that occlusion. It needs to bake that occlusion result to a texture. And ideally, it also needs to log its progress so that as your tool is computing, it basically tells your user, okay, I'm 50% done, I'm 70% done, or I failed, right? Something went wrong. So logging and providing feedback is a very important aspect of tool design. So ideally then we can also say, well, all great and well, but how do you make this work without somebody that does not have Houdini knowledge, right? Somebody that doesn't know Houdini. Well, we're going to abstract that away, that Houdini functionality, and we're going to say, well, I'm going to wrap this entire process with a PyQt PySide interface. So that is where a user can load a single asset or a bunch of assets, a text file that contains the asset names, set some parameters, and it should handle all the perforce operations for you. So perforce, that's your version control, could be with Git as well. So that needs to all happen automatically or automagically. Your user doesn't need to deal with that. Okay, so another kind of way to see divide and conquer is the approach from a layer-based approach. So yes, maybe you need to make a complex effect, but that complex effect breaks down in individual layers. So generally you've got your primary effects, you've got your secondary and your tertiary effects. So your primary, that is going to define the main timing of your shot. If you have that wrong, then you don't even need to worry about the rest of it because it's also going to be wrong. So what I mean by that is your fireball, in this case your explosion, your rigid body dynamic simulation needs to happen within a certain time frame, start and end of your shot, there's a certain duration to it. So make sure you get your timing right. And then after that, you can start researching your secondaries, such as your fluid simulation. Could be multiple simulations. There could be a shock wave. There could be a fireball. You can have some heat distortion element as well that can be used by the compositors to help build this shot and bring it all together. And then finally, you've got your tertiary effects. So the small scale stuff, your debris, some smoke trails, some sparks. So those are the effects layers, so to speak. Now, then we have the AOVs. These are the arbitrary output variables or your render passes, your effects comp as well, where you bring all of these render passes back together. Now, this is for a shot, but this is also true for games, right? Basically, you have render buffers. Same thing, you're doing compositing in real time, but it all applies. So you're not alone in a pipeline. You are working with other professionals, right? And so you're gonna need to go and think through the stages of either a shot or of the stages of your game. So we've got story, we've got design, modeling, look dev, animation, effects, lighting, compositing, grading. Now my expertise was originally in effects and now I'm in tech art. But as I maybe show at the end, before I started in effects, that happens to be what I enjoy and what I find most interesting, but there's all these other things, right? I was looking into ZBrush modeling, I was looking into rigging, cartoony rigging then into rendering and lighting as well, and then doing effects comps and compositing too. Now at varying degrees of success, but it is a good idea to at least understand these different stages so that you can talk with people that are doing those roles and that you can speak their language, their specific jargon, even if you're not the one that is actually going to fix the issue. Because sometimes the issue that you're trying to fix is better done at a different stage of the production pipeline. So same thing for the games, right? Story design, in the design phase specifically, the gameplay loop is very important to make sure that that game feels right. Like, what does it mean to have a game that feels right? Then there's the modeling and the texturing and the shading, so that's a lot of art, right? And animation as well, effects, lighting, and compositing with those G buffers. In terms of data, right, we're going to try to have an understanding of your data. That's actually really important as a technical artist, so that you are a master of time and space. Now that sounds a little bombastic, but what does that actually mean? Well, you need to know what is your vector data, right? Is it 0, 1, 2, T, 1, 1, 2? Is it ID passes? Is it red, green, blue, right? Is it that kind of vector data? Is it representing colors? Is it representing masks? Your 3 values could also be X, Y, Z. And what does that mean? Well, these are vectors, so it could be normals, it could be things like velocity, it could be position data, flow maps, that kind of stuff. And then we can also encode even gradients that store time information, such as your start, your end, and your duration, and that can be reveal masks or other kinds of trigger gradients. Data structures then, so very important. How are you actually going to store that data? So we can store things obviously in textures, pixels, that's extremely optimized for graphics cards, but also volumes and voxels, right? That's just voxels are pixels in 3D. So the benefit of understanding your data format is if, let's say, you have some experience in Photoshop and you know how to manipulate your pixels, well, a lot of that math and a lot of those manipulations will transfer almost directly to your voxels. You can blur your pixels and you can blur your voxels. You can sharpen your pixels, you can also sharpen your voxels. You can propagate masks and simulations through pixels. You can do the same thing in voxels. So very important data format. Then we have other things that we can do lookups on. Point clouds, right? Point clouds are extremely useful to have a simple representation of objects in your level. So that means instances, and we can put all kinds of data on those point clouds. That means things like positional data, things like maybe which biome or ecosystem that they're supposed to live in, maybe if they're a certain type, are they a piece of foliage, are they a piece of a VFX, do they need to trigger some animation, all those kind of things. Curves. Right, so next, polygonal curves or NURBS curves, right? NURBS curves maybe not used as much in games, but for a tooling point of view, curves can be extremely useful as helper objects. You want to grow trees along a curve, and you can generally define your hero helper object. Let's say this is my hero curve, and from that curve, I'm going to grow additional data, which then up-reses my detail of whatever model that I'm working on. You can use it to scatter, so that's a nice way to sort of say, I'm going to scatter a bunch of trees, I'm going to scatter a bunch of telephone poles, I'm going to create a river here, whatever it is. But it's a nice way to control your data and influence your data. It's also, I think, superior to just painting it, because then if a bridge moves or a level design decision changes, well, your curve is easy enough to manipulate, and then you rebuild your assets from there or rescatter them, rather than having them hard code painted in there, because then, well, now you got to repaint your data. Something on the topic of NURBS, right? So NURBS stands for non-uniform rational B-splines, which is a type of polynomial mathematics that comes into play later when you're doing interpolation. It's useful to understand a little bit of this data. How does that work? How can you sample these curves, right, with parametric coordinates? I mean, parametric coordinates, maybe you're familiar with UV coordinates, right? Those are parametric coordinates for a surface for 2D. Well, curves have parametric coordinates as well, and they're extremely useful to be able to sample certain tangent vectors or maybe density information from a curve. All right, lastly, polygons. We're pretty much familiar with polygons. Super useful to make rough masks about polygons. I'm going to take questions at the end, so I'll just revisit questions, sit on it for a moment, but I will come back to you. In terms of scripting, programming, it's not just all art. There is some Python power here. There are certain modules that I'd say, if you're going to do something, these are quite important. And sure, there might be new modules as we go and as Python evolves, but these are kind of like really important to get them down for integrating your tool into the rest of the pipeline. So the first one, import argparse. If you're wanting to create a tool that is allowing you to handle command line arguments, and before you even start thinking about an interface, command line arguments is fine, because you can still wrap that in a single line argument, and you can do CSV files around your argument and so on. So there's, even if you don't have an interface, handling command lines arguments is really important. So for those of you, just kind of mention that have never done this, right? Where do you start, right? Well, there are a lot of courses on Python and on handling all this kind of stuff on YouTube. So it's for free, all it costs you is your time. Scripting and Python programming in the future, and now already it's just a really, really good skill to have as a technical artist. Next, we have importing JSON data, right? So JSON files, what's that? Well, JSON data is, in essence, dictionary data, and basically it allows you to store any kind of key value pairs in a very efficient way and in a very multi-platform way. It's accepted by many languages, whether it's Java or C++ or Python, and there are libraries out there for you that you can use to basically use I/O, so easy input and output, easy read and write. You don't have to write all that functionality yourself. Right? There are other kind of formats, like say a CSV, a comma-separated value file that allows you to read Excel documents, things like that. But JSON is a really handy format to know, especially for metadata, because you could have your polygonal data, and then with that comes a description of what that actually polygonal soup ends up being. That can be in a JSON file. Importing PySide2. So PySide2 is interface related. Now, PySide2, why do I mention this one rather than say the import Qt? PySide2 is the open source version of Qt. Now, it is compatible with Qt Designer. Qt Designer is a program that, think of it like PowerPoint for presentations, while Qt Designer is a way to design interfaces for your code. So you can build your interface with Qt Designer and then you hook it up in your code with PySide2. A very easy way to build interfaces. Next, we have importing of logging. Now, I already mentioned whilst I was going through that abstraction case about logging and providing feedback to the end user, right? Now, logging is particularly useful. Maybe some of you that have used some DCCs, right, like Maya or like Houdini, are aware of render engines where you can set the verbosity, right? Verbosity, how verbose is your process? Verbose means how wordy, how much information does it spit out, and what kind of information. You have information at the info level, you have information at the warning level, and you have logging also at the error level. And so the nice part of that is you can split out these different streams of information. Some of you might be familiar, I'm just going to put a print statement in here, I'm going to print out a whole bunch of information. That's useful, but it's even more useful to be able to split that output into different streams, right? Into different logging streams. And then you can write that logger as a text file to disk as well, so that if something goes wrong with your tool, you can send that log to a technical artist like myself, and I can basically reverse engineer and go and find what went wrong. All right, next we have import who. So import who, I wanted to add this one because I do use that one a lot. That is a Houdini specific module. Now, most of you tend to use a DCC like Houdini or like Maya, generally through its interface and run scripts within Houdini. But you can also run Houdini through Houdini engine, which means through the command line. You don't open Houdini, you basically grab all of its Python functionality through this import who. So use Hython, that is Houdini's Python interpreter. And that way you get access to all that functionality, and also want to mention that a Houdini engine license is significantly cheaper than a full-on effects license. A full-on floating point effects license costs $7,000. A regular one, node locked, is $5,000. A core license is I think around $3,000, and then a Houdini engine license is I think around $700. Depends if you buy them in bulk, right? All right, so these are all useful things. Next, useful math, right? I hope I'm not scaring people with this. Math can be fun, right? Seriously, I enjoy math, but I got to say I learned to enjoy it by applying it within my own career or in my own projects. An example of that is when I first started learning sines and cosines, like trigonometry. Yeah, that's useful, but if you just learn it in an abstract school environment, maybe you're kind of like, well, why am I going to ever need this, right? And so at the bottom, you can kind of see an example of a fractal. Well, that uses sines and cosines. This happens to be a Clifford attractor, and the links are there at the bottom if you're curious about how you can make something like this. It's not difficult. You can do this in Houdini as well. You can do this in another application too. All right, so let's go through the ones that are particularly useful, right? So the first one, algebra. I put percentages next to them, like 55% and so on, in terms of how much of my day-to-day work involves these different portions of mathematics. So algebra, that's Most of you have had this, I would assume. Sum, summation, average, interpolation. So here we go again, right? That's that curve interpolation, or that could be interpolation between two UV coordinates or in three-dimensional space or between voxel data. Very, very important, interpolation. Next, we've got solving of equations. So that's basically if you want to say, I have to shoot a weapon and there is a parabolic arc to this, and I want to know, based off of gravity, where is my projectile going to land? Well, that is a quadratic equation that you will have to solve. So those kind of things are quite useful to be able to figure out. There's another one in there, fuzzy logic. And on the right top portion, I've kind of made a little, or I took this picture from Craig Reynolds' website, and that's about boids, right? Boids is kind of like all things flocking, right? So that means fish, that means birds, that means ants, ants, Ant-Man, you can kind of see where that came from. But fuzzy logic is extremely fun. I love that kind of stuff. This is part of chaos theory and chaotic systems, which means these are systems that generally are part of some kind of simulation, right? They're not really that predictable. A few small rules can have really complex outcomes. So those are very powerful systems, and fuzzy logic is part of that sort of branch of mathematics. Next, we've got vectors, right? So vectors, anytime you want to do anything with moving objects in three-dimensional space, or you want to do displacement mapping, you want to do flow mapping. Here I've mentioned also dot products and cross products. Super useful operations to be able to identify whether one object is facing another object, whether I need to create a mask out of, let's say, a dot product. You know, I want to do snow-covered things. I want to do X-ray or ghost-like shaders. You know, that's all dot product under the hood. Next, also we've got, there displacement, fluid and particle advection. So advection, advection, it's in the word, adding a vector to a particle. What does that mean? You're going to slowly start to move that particle. So if you want to start moving dynamic objects, whether it's particles or rigid body dynamic objects, that means you're going to need to deal with vector data and specifically that advection portion. Now, that also works for voxel data, right? Particle data, voxel data, even pixels, that all can be advected, can be moved around. Next, we've got coordinate systems, right? So most of you are familiar with the grid, right? That's the Cartesian coordinate system. But we also have spherical coordinate systems. And spherical coordinate systems are extremely valuable as well to be able to express rotations, right? So basically, that picture of that sphere there are different angles indicated, like theta and rho, and you know how you can read that. That's I'm going to leave that up to you. It's listed there in Wikipedia. But the point being is you can express a location on a circle using two angles, right? One rotates, let's say, around, and the other one rotates up and down. And based off of those two values, you can define your vector or your rotational data. So extremely useful as well. Next, we've got matrices. So let's go briefly talk about that, a whole bunch of ants, right? Sure, you can use the fuzzy logic to figure out a whole bunch of points that are crawling around. Well, that's not an ant yet, right? How do you turn that point cloud into a bunch of ants? Well, they have legs, and they have legs with a lot of joints, right? So this kinematics, this motion, this locomotion that you're trying to get out of that point cloud, how do you do that? And how do you make it so that these ants aren't just walking over a flat wall, they're walking over terrain and rocks and all of that kind of stuff. So each leg individually needs to solve an IK problem, an IK solution. It's going to do a raycast, it's going to hit the floor, and it's basically going to solve a cosine operation within its IK solver. So those kind of things, kinematics, FK and IK, bone hierarchies and locomotion, that all falls under matrices, because a lot of these are kind of how you're going to layer these matrices and create a hierarchy of matrices. It's like A multiplied by B multiplied by C multiplied by D, multiplying all of those together is going to give me the motion of my finger, and the motion of my wrist, and the motion of my forearm, and so on. And it's this hierarchy of motion and of matrices, that concatenation of the matrices, that is going to, from a technical point of view, produce that motion. Next, we've got trigonometry. Now we're down to 3%, right, of math that I'm using. So trigonometry is not something I use day to day, not that much. It's kind of expensive in games to do that real time. Yes, there are lookup tables, and you can do other ways around it. So Trigonometry is useful in certain scenarios. So sines and cosines, that can give you procedural motion. Let's say a tree. You can do a simulation on a tree and you get that kind of swaying motion back and forth, right? But you can also do that in a procedural manner where you layer sine waves, right? Sine waves one after another, and you put a bit of a delay between each of your joints, and you're going to get that kind of nice overlapping motion, right? And then you get a nice swaying back and forth, typical for grass or bushes or things like that. Now that's obviously procedural motion. You have also a simulated motion where you run, a proper, maybe a fluid simulation or at least a shock wave, so that you can influence your objects in game, and then that's different from, say, sines and cosines. Next, also with sines and cosines, is fractals. So maybe some of you have learned at some point in the past how to draw a single sphere or a single circle using sines and cosines, right? There's an equation that basically describes the coordinates of sines and cosines of a sphere, of a circle. Now what I've got there, that fractal, that Clifford attractor, that is a very complex looking circle, right? It's just, we've added more stuff to the equation, but in essence, to me, it's a circle, right? It's just a more complicated equation. And it's nice to start with a circle, work your way up to a more complex fractal, and then take this two-dimensional image and turn it into a three-dimensional image. And there's different algorithms with fractals that you can use to create three-dimensional data as well. Next, we've got quaternions, right? Quaternions, that's one piece of mathematics. Like, I don't use it that much, but it can provide really useful benefits. One of the things that I mentioned there is spherical linear interpolation. Jesus, that's a mouthful, right? What is that, right? Well, imagine you've got your sphere, right? And there are 2 points on your sphere, and you want to go from one point on that sphere to another. Now, we're not traveling in a straight line, we are traveling in a curve across the surface of that sphere. So why is that so important? Well, if you've got things like normals on your object, right? Or a direction vector of some sort, well, that normal needs to be of unit length most of the time. If you say something is a vector is normalized, it's going to be of unit length. And as that normal rotates from one position to another position, it needs to maintain its length. So we got to make sure that we basically are rotating across a spherical surface, and we can use quaternions to do it. All right. Now, for those that were a little bit like, wow, that's a lot of stuff, that's a lot of technical stuff, I want to talk soft skills, right? So now we're going to switch to a different mode, and that's basically LinkedIn and networking and how to approach that. So on the right side, I basically took a position in my LinkedIn and I put it as FX supervisor, and I've kind of indicated all of these keywords. So the first thing to note is that LinkedIn is a great platform, and in our industry it is used throughout. It is broadly used within the tech industry. Now it is for robots. And what do I mean by that is I did not make my LinkedIn profile for a human. I mean, yes, a human can read it, but really it's for robots, because individual recruiters are not going through profile by profile. No, they have filters and search algorithms that are going to look for keywords based off of their job description. So this is information that maybe hopefully can benefit you and how you design your own LinkedIn profile. I put a lot of things in there, such as, I mean, we can see from commercials all the different projects and what I did for each commercial in a brief line. And it's okay if your position ends up being like, a shopping list of all of these things that you've done. That's fine, because honestly, it's not the same thing as a CV. A CV is much shorter, and that is human readable. That is what you're going to send out, your resume basically in short, sweet, bullet points. But for LinkedIn, you want to hit the keywords. That's the important part. All right, so what else should you have there, right? So keywords we touched on, search engine optimization, right? That's kind of goes hand in hand with keywords. Have you typed your own profile in or your own name in Google? You need to do that and see if your LinkedIn profile, or in LinkedIn, put your name and see where do you rank, right? Add some more keywords if you need to. Other things that help with that is recommendations, right? I have something like, 10 or 12 people. I've recommended 10, 12 people. They recommended me for different roles. When I was an artist, when I was a lead, when I was a supervisor, at different stages. When I was a teacher, I taught at Nomen for a while at a university. Different things, right? And kind of all goes together in those recommendations. Because people will read those recommendations, because it's a hint, are you not only talented, but are you also a nice person to work with? Messages, right? Some of you have already messaged me. Some of you in this room have messaged me, and we have started conversations. That's a great platform to do it, because Facebook, no, not really. Email, also not really. I mean, it works, but messaging in LinkedIn tends to work well. All right, next, networking events for people, right? So this event right here, today, right? This is what I'm talking about. This is where you should be active. So user groups, conferences, whether it's GDC or it's maybe a Houdini user group, or it's a SIGGRAPH presentation. It could be FMX. There's other procedural, everything procedural is another one. Game jams. Some of you are part of game jam groups and create amazing things in the span of a weekend or even a week or 2 weeks, whatever it ends up being. These are great networking opportunities. After that, ask and provide feedback. So online forums, like my favorite forums are the Side Effects forum, the Oddforce forum. These are like my home turf. That's where I grew up on. And I would ask feedback often and early, and would provide feedback as well to others that were asking it. And the reason for that is because at some point I was trying to solve other people's technical problems, not just my own, but also their problems. And the beauty of that is, especially when I was a beginner, I knew that my solution was not the best solution. But on the other hand, I would post a solution. It would work. It would not be very efficient, but it would give some kind of output. And then some really senior dude comes by and is like, no, this is not how you do it. This is how you actually do it. Blah, 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 blah. And I'm learning, and the person who posted gets a great answer. And that is an amazing collaboration. But in the meantime, a couple of things happened. One, I thought really in depth, as my skills led me, through the problem, right, on that forum, and try to help that person. And it wasn't necessarily my problem, but I still want to help and see, could I solve that? Because ultimately, today, I get paid to solve problems, and they're not always my problems, they're other people's problems or in the pipeline. So it's a good skill to start, testing that, right? And there's different websites where you can do like, lead code, kind of things, coding examples to practice yourself. But it's also great to do that on actual practical problems that people have. Now, get feedback often and early. Sometimes I've run across people and they're like, no, my stuff isn't ready yet. I'm not ready to show it. I'm quite against that. I kind of would throw it around and say, I've seen people here put a blog, a developer blog. This is what I've done. This is where I'm at. This is where I was in January. This is where I'm at in February. This is in March. And now I'm refining it, right? And along the way, you're showing your progress. And that is actually really important as well, because that can show us, ooh, that's an avenue you went down to and it didn't work out. How did you overcome that? How did you kind of, create a better solution? Or did you come up with something different? How did you, overcome these struggles? Because it happens. Next, job hunting, right? Ultimately, well, we got to pay the bills, so you got to have a job. Where are good platforms to job hunt? Well, so LinkedIn is a good platform to job hunt. Zerply, that's specifically for creatives. Maybe some of you don't know about it. That's especially for people working in film industry, in commercial industry, advertising, those kind of industries. Creative Heads, another one. It's a bit of a mixed bag, that one. It does game jobs. It does other, other roles as well. Then we have got a little bit more for the tech side. That's definitely, there's more lean here for the programming side. So ladders, right? That shows you the trajectory of your career projection. Salaries at the higher level, we're talking 6 figures and beyond, right? At higher levels. Also, what does it mean to make a lead salary versus a director salary versus maybe just sort of a senior programmer or senior programmer level 2? What does that mean? And at Amazon or at Nvidia or at Activision, these levels can sort of be a little different. We've got Glassdoor on there as well. Glassdoor is more like an insight into a review of the company, right? A good idea to sort of have it check out what this company is all about. Also shows salaries, shows percentages. Oftentimes, I would say that data is a little bit out of date, so just keep it with all of this, by the way, take it with a grain of salt, right? It's good to talk with people and have direct experience. Like another thing is, don't go up to a person and say, hey, how much are you making? But it is fine to ask, hey, a senior technical artist, what is the kind of range of salary that I should be expecting or that I may need to negotiate for? That is totally fine, because you're not making it personal, you're making it generic, right? And that range, that's also important, because someone in San Francisco or someone in LA or someone in Dallas may be at a different sort of compensation rate. All right, next we've got levels.fyi, similar to ladders, right? So mostly for programming. Then I listed Blind in there. Blind is an app, so on your phone, and it's for tech companies as well, where you can get all kinds of feedback. Again, take it with a grain of salt. It's unsalted, unfiltered criticism about these companies. When there were a lot of layoffs in tech, there's a lot of information that you can find on there and really see why is it that certain teams at certain companies are doing well, or why are people moving around and trying to avoid certain companies. It's good to inform yourself, right? So that you don't join a sweatshop, but at the same time, also if that's what you want, or you want that experience, and you want like a lot of different projects to work on in maybe a short period of time, there's an advantage on that. But there's always a pro and a con, right? All right, next, side effects and authors job forums. So the side effects forum, that's the Houdini forum, they have on their forum a job forum. Some people, they just breeze over that and just go, oh, there's technical information here, there's art information here, there's a game forum, great. But they have job forums too. The Authors forum is also a Houdini forum, that's more a community forum, but they also have jobs there. So super useful to kind of learn about that. Sharing is caring, right? So this is an important aspect. Nelson already hinted at generosity, right? Give back whenever you can to the community. It's not only helpful to the community, but it is helpful to yourself as well. So YouTube is a great platform for doing that. Now, I have listed some of the YouTube videos that I've created. There's more on my YouTube channel. Shortest path finding things, dot product explanation, cross product theory. I mean, things I just brought up in math, but then also kind of not just math, but implemented within the context of Houdini as a platform. How do you actually use these things? So some examples: orienting objects on another surface, that's useful. Creating a custom velocity field, that's extremely useful to be able to art direct your simulations. Understanding the SDF, signed distance field. That's another one of these data structures that is a volumetric data structure that is super, super useful. Now, so YouTube is a good way to share your information, showreel, right? Make yourself a showreel. We can talk a little bit about showreels in the Q&A section if there is interest in that. Teach, right? So make tutorials, post a breakdown. Don't just post the final result, post a breakdown too. Now, the further you get in your career, the more of these final products that you have, and maybe you don't need to / want to integrate as many of these breakdowns anymore. That's optional. Now, teaching, or sharing first, ArtStation, Instagram, Twitter, I'd say Discord maybe as well. These are all great locations to share your art or your work. Teaching, Twitter, YouTube, and university. If you have the chance to be maybe a teacher assistant, or maybe do a guest lecturing class, or maybe actually teach a class, right? Teach a full-on class. These are all really useful things. As a matter of fact, one does not disqualify another. For instance, when I was at Method Studios and was working on Ant-Man, I was also teaching at Nomen. And the reason why I did that was because I wanted to bring in talent. I wanted to bring in great talent. Now, at that time, there were a lot of people moving to Vancouver or moving to Canada, or, basically outsourcing was happening and is still happening, right? This will always happen to some extent. So I was like, well, I need local talent. And instead of me sitting one-to-one with a person and explaining, I was like, I'm going to do that to a class of 20 people and just train that talent in bulk, and I'm going to hire the best people, right? And that's what I did. And so for 7 years, I would hire the best people and really grew that talent and did amazing work. And everybody benefited from doing that. So if you have that opportunity to teach, whether it's at a university or a school or a workshop like this, right? It's great. Do it. I highly recommend it. It's also a great opportunity to learn to speak and to talk and communicate to a crowd of people, right? Because as you eventually climb up the ladder in your company, you will be asked to present, whether it's to the president or vice president or general manager or whoever, right? And you're going to be more comfortable doing it. So take those opportunities on. We already went into asking and providing feedback, and then establish subject matter expertise. So as soon as you start to teach, right, not only are you going to post your thing online, you're going to have a whole slew of people that are going to comment, this is not good, this is great, this is not good, like all of that. Take that criticism into account, learn from it, but the more you do it, the more you are establishing yourself as a subject matter expert, and you can point to that. In an interview, right, if you're doing a job interview, you can say, well, I've been teaching this stuff. So obviously I know my cross product and my dot product. The proof is in the pudding. It's like there's no denying that, right? There's no Yeah, maybe he knows it, maybe he doesn't. No, it's like if you're explaining it, if you're teaching it to others, obviously you're going to know it and you're going to have to know it well. Your personal brand. This is another one, right? In the world of social media, there's different ways to see it at. I'm not talking necessarily about, oh, this is the latest thing I've done last weekend on Instagram. But your personal brand is actually important. If I ask any one of you, I need to be able to ask, okay, who are you, right? Sure, your name, fine. But what are you all about? What do you care about? What are your interests? What are your passions? What do you love working on? What do you represent, right? Are you more into the art side? Are you more into the tech side? Are you an upstanding citizen? Are you, honest? Are you kind? What do you offer? Maybe I'm representing a company and I'm looking for an effects artist. I'm looking for a great modeler. I'm looking for a kick-ass animator. Whatever it may be, yeah, you're going to offer something, and I can offer you something in return, right? So hopefully we can find, a win-win situation. So what do you want, right? Yes, money is one thing. Benefits, remote work, shares, a bonus, maybe 4-day work week, flex time. Maybe you've got kids or not, and you need to pick them up from school, whatever, right? There are different things that you as an individual may want and that a company can offer. So think about that when you're starting to talk with companies, because it is not that rigid. It really isn't. Certain things like, who's your 401k provider, this benefit kind of thing for investing and all that. Yes, that stuff can be quite rigid, but anything else is open for negotiation, and companies will work with you if they're really after that kind of talent. How can you be reached? Obviously, I need to be able to contact you, whether it's LinkedIn, an email address, an ArtStation webpage, a phone number, but I need to be able to reach you, and I need to be able to have that information fairly accessible, fairly easy accessible. Then, what is your business? Now, this one kind of diverges from all the other questions, right? I could say, what is my business? Well, these days, I could have said, I'm a YouTuber. That's not necessarily what I'm doing for my job, right? Or I am an investor. I invest my own capital into the market and I try to get some passive income out of that. That is a business of sorts. You could say I'm a teacher. I teach at Nomen, right? That is part of my business. So, or I sell products on Amazon or whatever it is, or I make games. I'm a game developer, right? Obviously indie game developers, there's a bunch of people here into that. So what is your business? That is very important because that's different from what is your job. You can work for your business, you can work one or multiple jobs for your business, and you can have a career and a job, but it is also important to eventually think about what is your business, right? How can you create something that produces income without necessarily, it can have your involvement, but it's a little different from the rest of your job or your brand. All right, what is next, right? So this is future forward, right? My upbringing and my generation is a little bit different in terms of my schooling is different from what is happening day to day these days. So machine learning, right, is everywhere these days. Generative AI, whether it's Stable Diffusion or Midjourney or things like ChatGPT and Copilot. So for those that may not know, ChatGPT, that's a large language model, right? So that basically is an autocomplete, but a very fancy one and a very powerful one. Even more so now that there are plugins that extend that functionality to interface with websites that book a flight for you, or the weather station, or maybe other things. So Copilot is Microsoft's version sort of ChatGPT that is soon going to be integrated with Office. So that means you can ask Excel to go and grab 10 of the biggest CEOs of the Fortune 500 companies and also find or make a short description of their resume or their life, their career, and put all of that into an Excel spreadsheet and write an article on that. Those kind of things are possible. Now, with Copilot, one of the things why it's relevant to us as technical artists is because it can also become part of VS Code, right? So Visual Studio Code, an IDE to program, and it can help to literally write code for you based off of a description. So you might write your doc string, right, your documentation string, and based off of that, it can figure out what you want your definition or your function to do. That's very powerful. You can even use it to write currently small applications, bite-sized functionality. I foresee that is going to boom even more. Soon, we'll see if Activision is going to be acquired by Microsoft. I anticipate we're going to use that within Activision as well. Right now, we are not allowed yet. Next, everybody loves nodes, right? So node-based working, whether you call it visual programming or building tools with it, it is everywhere. So that kind of wrapping your mind around being able to build bigger structures using nodes is going to be very important. Whether it's in Houdini, well, that's always been node-based, or now Blender, right? Not just with its geometry nodes, but soon also they add a simulation context to that, so you're going to be able to leverage that as well. Substance, right? Node-based shader work, right? Also very powerful. Unreal blueprints, and now in Unreal 5.2, the procedural content generation, right? All node-based stuff, right? Super useful to understand that. In Maya, it's Bifrost, right? Also very efficient way of processing data, including solvers data. And then we've got NVIDIA OmniGraph as well in there. So that's again a node-based structure where you can build things for NVIDIA Omniverse. Next we have Metaverse and Omniverse. So I would like to invite you to think beyond games or beyond film, right? We're really entering in, I think, a golden age for technical artists. Honestly, there's going to be so much opportunities in all of these different areas to help build this content. There's an enormous demand for it. So Metaverse, well, Meta, the company used to be Facebook, so they're more on the social side and integrating a social network for the Metaverse, right? So it's for those not fully familiar with it, think of it as a virtual environment where you can do pretty much whatever you want, right? So you can have a meeting, a conference, you can play games, you can watch a movie together virtually, whether that's VR, AR, sharing different things, teaching virtually, super useful to potentially do that. And I think in the future it's gonna be even more. Now NVIDIA, already mentioned it, they have Omniverse, that's more the corporate side of it. That's about making digi-doubles, about a digital version of your factory. Right? So you've got your assembly line, and you make it digitally as well. You can change your assembly line around, you can run simulations and models on that. Now, somebody at some point needed to put that technical assembly line together. Those are engineers, but also technical artists, right, to figure these things out. We then also have Epic. Epic is also trying to do it from more of a gaming point of view. They're, Fortnite, you could argue it's kind of an omniverse situation. It's kind of like where people are getting together and they're doing it for more than just gaming as well. Like concerts, right? Virtual concerts are happening in there. So I kind of included that one too. I already hinted at it before with the whole processing of 5,000 assets, bigger worlds, more assets. Every Call of Duty has been bigger, right? Bigger levels, open world, or large, 150 players all at the same time, and just more and more data, more and more interaction with that data too. So that means you can kick down a tree, or you can ride a vehicle, or you can fly a plane, or a helicopter, or maybe it's a boat that's driving around, or whatever. All those kind of things create a lot of complexity. And so proceduralism can help with that, whether it's to generate your world data, right? So to actually create your world in a procedural manner, that's super useful. Another thing that I foresee is going to play a huge role is synthetic data, and you can use Houdini or other ways to create that data mixed with ML, so machine learning. That is a killer combo. Anybody that knows enough machine learning and also knows ways to generate data to train your neural network on, super powerful. Because imagine for a second, well, I want to create a new map for Call of Duty. Well, we already have a lot of maps in our archive, and can I train my machine learning network on these layouts, on how artists have put things together, on how our operators are dressed, or how our guns are configured? Now, make a variation, make a new thing, make a Christmas version, make a Halloween version, whatever. All of those kind of things, that's going to be extremely useful. Next, we also have hero assets, right? So our hero assets are getting more and more complicated as well. So technical artists help, for instance, capture all of the facial data when we are doing live recordings. So we have hero actors, and they have facial data, and machine learning is used to train a network to extract the optimal blend shapes out of a facial performance, and then that makes it into the game. Other things we use that for as well is like sort of subsurface scattering algorithms to put like a dome of lights around the character, and we flash them from different sides to get all of this light information and extract the parameters that will drive our subsurface scatter shaders, those kind of things. Now, say that's at the Call of Duty scale, so that is, we're doing a lot of scanning, a lot of data processing, but bigger worlds and more assets, it is going to be prevalent, right? Everywhere basically. More computational power, and specifically in the palm of your hand. I hate to say it because that quote that killed Blizzard a few years ago was like, "You all have phones," right? I don't know if you know that quote, but if you do, then you know what I'm talking about. But it's kind of true, though, to some extent, is that the power that an iPhone has these days, not just as a device to play a game on, but also as a capture device. Your camera, and some of these iPhones have like 3-dimensional capturing opportunities as well, is actually really powerful. You can capture data pretty much from anywhere. So this amount of computational power also in the graphics cards comes back as well, and it's only going to increase. I mean, things like ray tracing, well, that can influence how you design your shaders as a technical artist. But the next thing as well is, for instance, physics, and specifically destruction of your games, and how that can change the game experience. If you blow up a building and the entire building goes down, well, now you've killed 3 players that were hiding in that building, right? Things like that. So physics-based gameplay, I think, is going to have a renaissance, or even just even a growth as the computational power increases, because so far it's all been graphics, graphics, graphics. But actually there is so much more, and that's why I think it is a great time to be a technical artist. So for my contact information, you can find me on LinkedIn. So for those of you that have not yet connected with me on LinkedIn, please go and look for me, connect with me, I'll add you, we can message and start a conversation. If possible and where appropriate, I could maybe even give some recommendations or forward recruiters to you. I get a lot of recruiters reaching out to me about all kinds of roles. Not all of them are applicable to me, nor am I looking right now, but I can forward them. I can also try to find or help you find a job within Activision. Now, I have to give the caveat that since 2 weeks ago, they unfortunately largely closed remote work, which I'm not gonna lie, I thought that sucks. That's a stupid decision in my opinion, but that is above my pay grade. I cannot control that. Now, we have an office in Austin, so Infinity Ward has an office in Austin as well, so that's at least still within Texas. So there are people being hired into that office too, so not too far from Dallas. My YouTube channel is listed here as well, so for those of you that have an interest in that, I have 2 YouTube channels, one on CG stuff and another one on finance related stuff. The finance related stuff is more like about investing, but also there's some interesting stuff about career progression, salary negotiation, and also that was at the time I was an effects artist or an effects supervisor, the progression of your salary as a junior effects artist to sort of a senior, a lead, a supervisor, and then beyond. Like, how does that work? What's the difference between a lead and, say, a senior, right? One is more of a people manager, another is more like, okay, I'm gonna really dig into the technicalities of all these solvers or rigid body dynamic systems or whatever it ends up being. So you can find that on YouTube. So yeah, that's sort of what I wanted to share with you today.
Hey, thanks for watching. I hope you benefited from Peter's talk, and be sure to check out our playlist on the Tech Arts Meetup's presentations if you like more talks like this, or you can always check out more of our videos over here as well. So I hope to see you around, and take care.